high-end detectors have one thing in common, is that they produce a lot of images, meaning they produce a lot of data that you need to manage. And this is, of course, not just a challenge for microscopy systems provided by us, but it's a common challenge in digital microscopy. And also, the problem is not, or the challenge is not new. It more or less emerged when digital microscopy came up, but it's something which is constantly increasing, and we are constantly acquiring more and more data. So what are the main drivers for this constant data growth? Which is, I think, first and foremost, we have more and more powerful detectors and imaging systems. So systems become more capable with larger camera chips, multi-camera systems. We have automation, higher frame rates, etc. And these kind of more capable systems also allow you to image very large samples, like Jürgen just mentioned. With you can image an entire mouse with a LCS spin system, but not just larger samples. You can also image many samples using automation, and you can image live samples at very high spatial temporal resolution, also adding to the flood of data. And also, like, high-end imaging systems are more widespread nowadays. Like a high-end light sheet system, probably 10 years ago, was only available in a few dedicated facilities. Today, you find them at much more places, so more users have access to the system, so more usage also needs more data. And this is not just the topic of microscopy, it's a topic in other life science disciplines as well, like spatial transcriptomics, other omics technologies, electron microscopy, etc. You name it. And so what are the main challenges is these large amounts of data impose? I mean, very obviously is if you generate massive amounts of data, you have massive storage needs. So you need to save it somewhere and store it. And these very large terabyte scale data sets of increasing complexity also generate some data management problem, organizing the data, annotating the data, providing access to the data, and so on. As the volumes become very large, you can also be confronted with performance bottlenecks, like you need to process all this data. So you need very fast read and write speeds of your disks to properly process the data. You need to transfer the data, which can be challenging if the data is very large. You may have security issues. So most simple security issue is you need to back up your data in case you have some kind of emergency and you lose your storage space. So already here you double your data sets. And last but not least, I mean, there might be some limited expertise and resources for handling these large data sets. And what I mean with that is very often people then try to use common technologies used in the consumer world, or even office technologies to deal with these large data sets, but often they are not really compatible, and it's very tedious to work with these solutions. And other solutions that are potentially compatible with these large data sets are often more kind of sophisticated, complex IT solutions, which are not always easy to manage by lab scientists, or simply you don't have the resources to deal with these systems because you need additional personnel or you need additional training and so on. So how does the current situation often looks like in laboratories or facilities? Of course, that's a very oversimplified scheme, but it probably will give you an idea, and you probably will agree with it. So what you often have is let me change to pointer. What you have multiple detectors. Each of these detectors or microscopes has its own control PC or acquisition PC. And then on top of it, you have multiple users in the facility or in the lab. You have multiple workstations, and somehow you need to bring the data from the detector or the microscope to the workstations or the PCs of the end users. And this is already quite some bottleneck. I mean, still very often people handle with external hard drives, and then just getting the data on the hard drive, getting it off the hard drive is tedious, takes a lot of time, leads to data duplication, partial copying. It's also not very safe to keep this data here. Of course, better to do a network transfer. At many institutions, you're still faced with a 1G network, which is fine for smaller data sets, but as soon as you start working with terabyte scale data sets, that becomes tedious to use and very slow. Like you can have NAS, which is better than external hard drives, the standard NAS, but still you have a transferring issue, or you can have cloud solutions, which are kind of state-of-the-art solutions, still the bottleneck remains, how do I get my data into the cloud? Uploading multiple terabytes can be challenging, and getting it back to a workstation can be challenging as well for subsequent analysis. You may analyze it directly in the cloud, but often managing and providing access to end users to these kind of systems can be complicated as well, if not managed by the institution. So what we need is to somehow reduce this step to increase the efficiency of handling this large amount of data in a straightforward and easy manner. And this is what we propose with the 𝗕𝗏𝗴𝗵𝗁. So the 𝗕𝗏𝗴𝗵𝗁 is a modular IT platform for large-scale data handling and processing, tailored for large-scale microscopy data, so image-based data sets. And it more or less replaces the other solutions I have shown you on the previous slide. So you will have your individual imaging systems, but the idea is that these individual imaging systems directly stream the data to the 𝗕𝗏𝗴𝗵 system using fast 10G network. And then the 𝗕𝗏𝗴𝗵 is not just a storage solution, but you can also process your data directly on the Hive, and it provides you a multi-user environment. So all the different users of the different systems can connect to the 𝗕𝗏𝗴𝗵, usually using remote desktop, either in the local network or using VPN applications. It comes with a built-in VPN application, so you can access the data from anywhere where you may work or wish to work. So what is a Hive? The main functionality of the Hive is provided by 3 modules. And these 3 modules are indicated here. So we have the Hive core, the Hive data, and the Hive net. And the Hive core is a kind of computing unit of the Hive, which is a high-performance computing workstation, again, tailored for the analysis of digital image data coming from microscopes. It provides multi-user access and remote connectivity, and is already equipped with a very fast SSD RAID storage, providing you high I/O for any kind of processing tasks or visualization tasks. The second main module is a Hive data, which is our storage module, which comes with a high-performance RAID 6 storage. Individual data modules come in sizes between 100 and 300 terabytes. It's designed for 24/7 data protection, and you can add multiple of these data modules to an individual Hive, so you can modularly expand your Hive to up to 1.5 petabytes. And the last main module is a Hive net module, which is our networking module, providing a secure and reliable 10 gigabit networking, so you can plug all your devices, and if you wish, even your workstations and user PCs to the Hive net, so providing access to the data and the computing capacity of the Hive. It seamlessly integrates into existing infrastructure, so you don't have to change your infrastructure on site. It actually expands your existing infrastructure, and it comes with a UPS, so universal power supply, which protects your system in case of a power outage, which can be dangerous to RAID systems. So with the UPS, your data is always safe, even in case of power loss. And you can have optionally a firewall to provide you some security from external threats. So it's a modular IT system, but it's actually a very easy to use system, and you don't need to be an IT expert to use it. First of all, it's a Windows-based system, so if you can handle a Windows PC, you will be good in handling the Hive as well. And for the administration and management of the Hive, we provide an application called the Hive dashboard, in which you can monitor system health, like state of your individual drives, state of your RAID. You can check the battery status of the UPS, and you can also use it for user management, like adding, removing users, defining the state of the user, should it be an administrator or a standard user, should the user have remote access, and so on. This is all possible from within the dashboard, and you can manage individual project, which means a project in this case is kind of a shared folder, so you can manage access rights to individual data sets sitting on your data module. So I mentioned it's a modular system, and I talked so far about the 3 main modules, the core, data, and net, but the Hive ecosystem is a little larger, so there are additional modules. You can have also a Hive GPU module, where you can have multiple GPUs attached to your main Hive systems for GPU processing, deep learning applications, and you can have a Hive set, Hive satellite, which at the end is a high-performance workstation with which you can expand your computing power of the Hive and maybe also use it to encapsulate certain projects on a dedicated workstation connected to the Hive system. And lastly, I mean, it's also we have a RAID system on the Hive, and the data is relatively safe in case of emergency, being in a fire or whatsoever. You should still back up your data. And if your institute is not providing you infrastructure to back up large amounts of data, we can provide you with a Hive backup system for offsite data backup. And to give you an idea how this could look like, this is a picture taken at the customer side. So you see here in total 7 modules, 2 net modules, several data modules. You can also integrate existing infrastructure you have if you have some NAS systems very easily to the Hive system. And then you can kind of combine different modules to match your individual requirements. So, and to summarize, I mean, what is a Hive? In an essence, it's a turnkey solution for handling large amounts of image data and the processing of this data. It's a tested and proven product. It's around for almost a decade, and we have more than 150 installations worldwide. It readily integrates into your existing infrastructure. It can be, as I mentioned, configured according to your requirements, and you can also expand it later on. You don't need to be an IT expert to handle it, and if you still have an issue, we have a very strong support for the system, so just drop us a message and we will help you fixing any kind of issue you may have with the system or data management issues, software licensing issues, just contact us. As it comes with remote accessibility, you can access the data worldwide, which also means it's ready for collaboration. So you can give access to your remote collaborators, to your data set, maybe an external image processing expert, to work on the Hive system from anywhere on the planet. And at the end, the Hive is part of the Bruker family. So you have a very strong partner with local contact and support for the system.